Hello. Here's the answers from those last two problems that we worked on the board. You can look back at those videos to see how those answers were worked out. And next, we're going to return to addition and subtraction. A little bit of a break from multiplication, although, as you'll see from example problems pretty soon, all the operations are going to be used together. For sets, this is some of the theory that we're going to be using in order to solve some word problems. In terms of sets, we can write down the number of items in them using addition and subtraction whenever there's a union or a complement involved. Here's an example with a small set of the numbers 1 through 7. That's U, the universal set. And I picked a couple of subsets of that, A and B. So, first of all, when A intersect B is the empty set, in other words, there are no overlap, we say they are disjoint. They don't intersect each other. Then the number of items in the union is equal to the sum of the number of items in the two sets, A and B, which you can see pretty quick from the example. That's the simplest addition. Here's the simplest subtraction. When U is the universal set, then the complement of A is counted by the number of items in U minus the number of items in A. So there are four elements in the complement of A, as if you look back at the example, you can see those four are 4, 3, 7, and 6. Some of them are in B, but we don't care. Those are all the things not in A. Here's a little bit more in depth. When you have the disjoint sets, then if you look at the complement of A union B and you want to count those, putting those two facts together previously means that you can take the number of total items in U and subtract both A and B. It makes perfect sense when you look at the picture, and you end up with the two items that are in the complement of A union B. In this case, that's 4 and 6. All right, now let's make it a little bit fancier with some overlap between the sets. So when there's overlap, you have to avoid overcounting. Here's what I mean by that. Here's a couple of examples of A and B, different than the previous one. The same universe though, 1 through 7. This time the A and B overlap. So you could do this a long way. The first one is sort of a long way. A union B. By forcing it to count up the things that don't overlap at all, just looking at the picture. You could do A minus B. That doesn't overlap with B at all. And then A intersect B is just the middle portion. And then B minus A would be just B minus all the A. So there's 3 items in the first, 1 in the middle, 1 in the last, and they add up to 5. Here's the shortcut. You can use the previous idea where you add together the two sets, the numbers of items in the two sets, A and B, but then what's happened is you've overcounted, so you have to subtract the number of items in the intersection. From the example, you'll see that there's 4 items in A and 2 in B, but the shared stuff, that 7, gets counted twice there. It got counted in because 7 is in A and because 7 is in B. That means you just need to subtract one of those, that is, subtract the number of things in the intersection, and you're back to the same answer we got before, 5. It doesn't look like that's that much of a shortcut, but it really helps a lot when the sets are big and you can't figure out the 3 pieces that we did in the first one. It's much easier to figure out the second one. Let's see. Right. So you can also do that with the complement. The complement of A union B then would be all the items in U minus the items in A minus the items in B. But then you have to add back in the intersection. So Basically what that is the complement of A union B counted is all the items in U minus the stuff that we just found, the formula for A union B number, the number of items in A union B above. So the minus sign goes on the A and the B, but then a double negative goes on A intersect B. And this time you get the 7 for the total, minus 4, minus 2, plus 1. So you get 2. Back to the picture. There's 2 items, 5 and 6, in the complement. Now, for 3 or more sets, you can keep this up. You can alternately add and subtract the overlaps to get the totals. So here's an example where there are 3 sets, A, B, and C, still the same U, and they all overlap each other. It's a classic Venn diagram where there's an intersection between any 2 and an intersection of all 3. So here's how you count them all up. A union B union C using the shortcut method. You first add together the numbers of items in each of the 3 sets, then subtract all 3 of the big intersections, then add back in the final triple intersection in the very center. So you notice like that, look at what happens to that 7. When you add together the A, the B, and the C, it counts 4 plus 3 plus 4. 7 gets added every single time. It's in A, B, and in C. Then you subtract the intersection. 7 gets subtracted all 3 times because it's in each of the 3 intersections. And that's why we have to add it back in once more to make sure we actually do count it. And we get the right answer. There's 6 items total. So that also works with the complement. If you have those same 3 sets, A union B union C complement, you start by just adding up the whole set U, then subtract everything that we just did. So you subtract all 3 of the sizes of the individual sets, then add all 3 of the sizes of the intersections, 2-way intersections, and then subtract the 3-way intersection. And you could go even farther. You could do 4, 5, 6, as long as you alternate subtracting and adding intersections. Yeah, so they can see that the answer is correct. That one item that's left out is the 5. But the answer is 1. There's only one item left out. Now here's a pretty hard example. How many pins, personal identification numbers, with 5 digits but no repeated digits at all? We've done that before. The first digit cannot be 0, the third digit cannot be 2, and the 5th digit cannot be 5. So your examples have to obey all 3 rules. The idea is to let U be all of the 5-digit pins with no repeated digits. So that's something we can count. It's 10 permute 5. Then you write down, I'll call by name the 3 ways of breaking a rule. A is the pins with the first digit 0, B is the pins with the third digit 2, and C is the pins with the 5th digit 5. Those are all illegal, but they overlap because you could certainly have the first digit 0 and the third digit be 2. The legal pins are the complement of those 3 sets. Those are all the ways of breaking the rules, and when you complement them, you'll have the ones that you're allowed to keep. So we'll work this out on the board.